Okay, hello everyone. So today we will learn about trigonometry. So the learning objective for today are to understand angles and then to define and identify the basic trigonometric functions and inverse trigonometric functions, and then to define and apply trigonometric identities, and lastly to solve trigonometric functions. Okay, the first part is angles. So these measures is determined by rotating a ray starting at one side of the angle. So this one side we call initial side to the position of the other side, which is the terminal side. Okay, if you look at this one is the initial side and then this one is the terminal side. So we rotate from initial to terminal, so we get the angle here. Okay, and then a common endpoint is the vertex of the angle. So the common main point here is this one, this point. So we call the vertex. Okay, and then the counterclockwise or anti-clockwise generates positive measure. So let's say we have this one. So from this one, the red one here is the initial side, and then this one is the terminal side. So we rotate counterclockwise, we get the positive measure. So for this one, we have the positive 45 degree. And then clockwise rotation generates negative measure. So that means from the initial to the terminal, we rotate clockwise. So we get the negative measure. So negative 315 degree. Okay, and then an angle can be named by using the name of its vertex. So let's say over here the vertex is B. So we can say this one is angle B. Or alternatively, we can use three letters. So the vertex letter is in the middle. So let's say this one, we can say angle ABC. So the vertex is in the middle, or angle CBA. Okay, so this one is actually the symbol for angle. It's like this. Okay, and then the Greek letter theta is normally used for the symbol of angle. But sometimes we can use other symbol as well. We can use X, alpha, or anything. Okay, so the most common unit for measuring angles is the degree. So basically, we have, look at this, we have a circle. So a circle comprised of 360 degrees. So over here, the positive x-axis is the 0 degree. And then we rotate, one rotation, we have 360 degree. Okay, and then over here, the y-axis is 90 degree. And then over here is 180 degree. Over here is 270 degree. And then lastly is 360 degree. Okay, and then basically degree are the one used to describe the size of angle. Okay, and then 1 degree, so we written as this one, actually represents 1 over 360 of the complete rotation. Okay, and then this one 90 degree is actually represent the 1 over 4. So we have this one 90 degree from here up to here 90 degree. And then 180 degree represents half of the complete rotation. So the 180 is actually from this one up until here, 180 degree. Half of the complete rotation. Okay, another unit to measure angles is actually radians. Or we can use radians for radian. So 1 revolution or 1 rotation measured in radians is actually 2 pi. So basically from here, starting from positive x-axis, so 1 complete rotation is 2 pi. So over here start 0, and then we also get 2 pi here. So that means half of the rotation is pi. So pi corresponds to 180 degree, and then 2 pi corresponds to 360 degree. So this one, pi equals to 180 degree. Okay, and then from here we know 1 radian equals to 180 divided by pi. So 1 radian is equivalent to 57.2957 degree. Okay, and then let's say we have like 2 radian. So 2 radian will be equals to 2 times 180 degree and then divide by pi. Okay, and then this one we get 114.59 degree. So from here actually we can get this one. Let's say we have radian and then we want to find the value in degrees. So basically it's equals to the radian times 180 degree divided by pi. Okay, it's like this, the one I showed you. So we have the radian, which is 2 radian, and then to get the degrees is like the radian times 180 degrees and then divide by pi. So these are types of angle. So we have first acute angle. So acute angle is the one between 0 to 90 degree or less than 90 degree. So this one we have the acute angle. Okay, and then second one is right angle. So this one measures exactly 90 degrees. So we have theta equals to 90 degrees. So this one. So normally for right angle, we put this one. Instead of this one, we put this. So this one means it's 90 degree. And then obtuse angle is more than 90 but less than 180. So we have this one from 90 degree to 180, obtuse angle. And then straight angle. So straight angle measures exactly 180, which is this one, straight angle. And then reflex angle is from 180 to 360. So basically from here to here, the reflex angle. And then full angle. So the full complete circle, exactly 360 degree full angle. Okay, let's look at example. So find the measure of each marked angle in the following figures. So if you look at this, we have this one, which means the total here, angle is 90 degree, the right angle. So that means 6x degree plus 3x degree. This one is equals to 90 degree. So this one 6x plus 3x, we get 9x equals to 90. So we solve, we get x equals to 10. So same goes to second one. So second one we have actually the straight angle, which is 180. So we have 4x degree plus 6x degree equals to 180 degree. So this one is 4x plus 6x, we get 10x equals to 180. So x equals to 18. Okay, so an angle is in standard position if its vertex is at the origin. So the vertex here is at the origin, 0, 0. Okay, and then the initial side lies on the positive x-axis. So basically this one is the initial side, positive x-axis. Okay, so for example, the angle in A is in standard position. So we have the vertex at the origin and the initial side is here, and then terminal side can be in anywhere. So let's say terminal side is here, so the angle is this one. And then normally we know if we do counterclockwise, so the angle will be positive, and then if you do counterclockwise, and then the angle will be negative. And then an angle in standard position is said to lie in quadrant in which is terminal side. So if it's lie in this one from 0 to 90 degree, so this one is the quadrant 1. And then if it's lie from 90 degree to 180 is in quadrant 2. And then if it's lie from 180 degree to 270 is in quadrant 3. And then if it lies in between 270 to 360, which is this one, is in quadrant 4. So basically this one 1, 2, 3, 4. 3, 4. Okay. Okay, and then we know acute is actually from 0 to 90. So basically acute is in quadrant 1. So this one. And then obtuse is from 90 to 180 degree. So basically it's in quadrant 2. Okay, so figure B shows the quadrant, the angles for each quadrant. Okay, next we will look at coterminal angles. So the coterminal angles are angles in standard position. Okay, so standard position, the vertex is at the origin, and then the initial side is the positive x-axis. And then share the same terminal side. Okay, let's look at this one. So this one we have the terminal side is here. So the initial side is here. So let's say we read this one. From here to here is 45 degree. Okay, and then we can add one more rotation. So this one, and then add one more rotation up until this terminal side. So basically the 45 degree plus one rotation, one complete rotation, which is 360 degree, we get 405 degree. So that's why we get this one is 405 degree. So these two are what we call as co-terminal angles. Okay, so they have the same initial side and also the same terminal side. So the co-terminal angles can be found by adding or subtracting multiples of 360. So because we add a rotation or many rotations, or we minus the rotations, where one complete rotation is 360 degree. Okay, and then the co-terminal angles have different amount of rotation. So the first one, 45 degree, we don't have one complete rotation, but the 405 degree, we have one complete rotation. So this one, 45 and 405 are co-terminal angles. So they share the same initial side and terminal side, but have different amount of rotation. Okay, let's look at example. So find the angle of least positive. So we want theta is positive, but the least positive that is co-terminal with each angle. So the first one, we have this one, 908 degree. So what we can do is we can just minus 360 degrees. So we minus one complete rotation. So this one will give 548 degree. And then we can minus again the 360 degree. So this one will give 188 degree. And then we can try minus again. And then when we minus, we get the negative angle. So, but since we want the least positive, so the answer is this one, the least positive co-terminal. Okay, and then for this one, again the same. This one, since this one is negative and we want positive, so we add 360 degree. So negative 75 plus 360 degree. This one equals to 285 degree. So straight away get the answer. Or for this one, actually you guys can draw. Okay, so let's draw this one. So since this one is negative, so that means it's actually we read this one, the clockwise direction. So 75 will be in this one, this quadrant. So we read like this. So this one is negative 75 degree. And we want the positive measure. So basically we want to read counterclockwise, which is from here to here. So since we know everything, one complete rotation is 360 degree. And then we minus the 75 degree, which is this one over here. So we get the answer is the same answer, 285 degree. Okay, next we will look at trigonometric function. Okay, there are 6 trigonometric ratios that relate angle measures of a right triangle to the length of its sides. Okay, so the ratios we call trigonometric functions, which are the sine, cosine. So the cosine I will just call cos, and then the tangent, cosecant. So for cosecant, it's either you use CSC or you can use COSEC. Cosecant. And then secant, another one is, the last one is cotangent. So we have these 6 trigonometric functions. Okay, this one just want to recall, if you have like this, the right angle triangle. So the right angle triangle is actually, we have one right angle here, 90 degree over here. Okay, and then let's say we have over here is the theta angle. And then here, since this one is the adjacent to the theta, so this one is, we call adjacent. And then this side, since this side is the opposite of this angle, so we call opposite. So adjacent is A, opposite is O. And then this side, the longest side we call the hypotenuse, H. So this one we know, sine. So let's say this one is theta. So we have this one, sine theta, or here is sine A equals to, this one we use the Soh-Kah-Tua formula. So this one is the sine theta equals to opposite over hypotenuse. The opposite over hypotenuse, so the opposite will be this one, the A over C. Okay, and then cos is the Kah. So adjacent over hypotenuse, and then the tangent is Toa, opposite over adjacent. Okay, and then this one, cosecant, secant and cotangent. Okay, cosecant is actually equals to 1 over sine theta. So if sine is or opposite over hypotenuse, so cosecant will be hypotenuse over opposite. Okay, and then secant theta is actually 1 over cos. So if cos is adjacent over hypotenuse, so 1 over cos, secant theta will be hypotenuse over adjacent. And then cotangent, cot, equals to 1 over tangent theta, which is adjacent over opposite. Okay, so make sure this one is secant 1 over cos, cosecant is 1 over sine. So now we want to define the trigonometric function using the xy coordinate. So how to do? So we start with an angle theta in standard position. So that means the vertex is at the origin, and then the initial side is this one, the x-axis, positive x-axis, the initial side. Standard position. Okay, and then choose any point P. Okay, so let's say now, let's look at this one example. So let's say now our terminal side is this one. Okay, and then we choose any point P. So we choose this point as P. So we choose this point as P, and then the P having coordinates x, y. And then on the terminal side of angle theta, so this one angle here is theta. Okay, so perpendicular from P, the point P, so we make one line perpendicular to the x-axis. So basically the one line is this line, perpendicular to the x-axis. And then this line actually will form a right angle triangle here. So over here is the 90 degree right angle. Okay, and then this triangle, right angle triangle here, having the vertex O, P, and over here we put Q. Okay, and then since the coordinate point is x and y, so that means over here is x. So the distance from O to Q is x, and then the distance from P to Q is y. Okay, and then next we find the distance r. So the distance r is actually from 0 to P, r. So to find r, we can use two formula. So the first one, you can use the distance formula, or the second one, we can use Pythagoras theorem. So the reason why we can apply Pythagoras theorem is because this triangle is a right angle triangle. Okay, so remember, if we have like this, right angle triangle, this one is A, this one is B, this one is C. So the Pythagoras theorem we can have is like C equals to, the hypotenuse 1 equals to square root of A squared plus B squared. So using this, we get R, the hypotenuse, equals to square root of x squared plus y squared. Okay, and then if you want to use the distance formula, so we want the distance from O to P. So O is the origin, which is this one, 0, 0, the coordinate. And then P, the coordinate is xy. So we have the x1, y1, and x2, y2. So we just substitute inside this formula. So we get the same final result for R, which is the same as Pythagoras theorem. Okay, now we want to define the function. We define the three functions, which is sine theta, cos theta, and tangent theta using the x, y coordinate. So if you look at this triangle here, so we know this one, the distance from 0 to P is R, and the distance between P and Q is Y, the distance between O to Q is X. So if the theta is over here, so basically this one is the adjacent, the Y is actually the opposite, the R is actually the hypotenuse. So we know sine theta. Okay, sine theta is equals to so this one so kah tua. So sine theta equals to opposite over hypotenuse. So the opposite is y over hypotenuse, which is r. So that's why we get the formula y over r. Okay, and then cos theta. Cos theta is kah. So adjacent over hypotenuse. So the adjacent is x, hypotenuse is r. So that's why we get x over r. And then tangent theta is toa, opposite over adjacent. So the opposite is y, and then adjacent is x. So we get y over x. So whenever we have the angle on the coordinate, and then we know the coordinate xy on the terminal side, then we can use this formula, these three formula for the trigonometric function. Okay, this one I showed if the angle is in the first quadrant. So let's say now the angle is in second quadrant. So the same thing, we choose P. So let's say we choose P over here. And then the coordinate is xy. So basically the theta here is this one. So we draw the perpendicular line here, making it right angle triangle. Okay, it's actually the same thing. So over here, the distance from 0 to Q will be x, the distance between P to Q will be y, and then the distance between O to P will be r. And then same goes to for the third quadrant. So same goes to for the third quadrant. And then we can choose this one as P. And then the coordinate is xy. And then we draw perpendicular line to x-axis. So we make it triangle. So basically theta is over here. And same goes to the fourth quadrant. So let's say this one is P. Coordinate is xy. So we draw perpendicular line to x-axis. So we make right angle triangle. So if you look at this, theta is over here. So this one is the first quadrant, theta is here. Second quadrant, we will have theta is here. Third quadrant, the theta will be here. The fourth quadrant, theta will be here. So when we have theta like this one is actually we call as reference angle. Okay, this one I'm pretty sure you guys came across this reference angle when taking the SPM. Okay. So I just want to recall this one, reference angle. Okay, another three functions are actually the reciprocal functions. So the cosecant is actually reciprocal of sine theta. So this one, the cosecant or CSC, theta equals to 1 over sine theta. So that's why we call reciprocal of sine theta, and then secant theta is the reciprocal function of cos theta. Cotangent theta is the reciprocal function of tangent theta. Okay, so we just swap the adjacent, hypotenuse, and opposite. Okay. Okay, let's look at example. So for this one, so the terminal side of an angle theta in standard position passes through the point 815. So we can draw first. So it's in standard position. So we have vertex over here, origin. And then the terminal side pass through point 815. So 815 will be somewhere around here. So let's say this one is 815. So the terminal side pass through this one. So that means this is the angle. Okay, and then we can draw the line, perpendicular line. So we make right angle triangle here. So this one is the x, this one is the y. So since we have the x and y, so first we find this one. We find the r. We find the distance from O to P, which is r. So to find r, we use we use Pythagoras theorem. So r equals to square root of x squared plus y squared, which is 8 squared plus 15 squared. So r equals to square root of, okay, just give the final answer. The final answer r is equals to 17. And then we want to find the values of the three trigonometric function. So when the question asks three trigonometric function, is actually the basic function, the sine, cos and tangent. So we find sine theta equals to y over r. And then y is 15, r is 17. So we straight away get 15 over 17. Then cos theta equals to x over r. So x is 8 over 17. And then tangent theta is y over x. So this one equals to 15 over 8. So we straight away get the answer using this formula. Okay, let's look at another one. Okay, the terminal side of an angle theta in standard position passes through the point -3, -4. So the standard position, so the initial side is over here, and then the terminal side passes through -3, -4. So -3, -4. So let's say over here is the point -3, -4. So the terminal side will be this one. Okay, basically the theta is here. Okay, so that means the reference angle is actually this one. This is the reference angle. So this one, we know x is equals to -3, y equals to -4. So first we find r. So r equals to square root of x squared plus y squared. So -3 squared plus -4 squared. So we have r equals to 5. And then find the values of three trigonometric functions. So we want sine theta, cos theta and tangent theta. So sine theta equals to y over r, which is equals to -4 over 5. Cos theta equals to x over r, which is equals to -3 over 5, and then tangent theta equals to y over x. So y is -4 over x is -3, which is 4 over 3. Okay, 3. Find the values of three trigonometric functions for each angle. So we want sine, cos, tangent for this one, this angle. So we have angle of 90 degrees. So we can draw . So basically 90 degrees from this one, positive x is this one over here, this one. So let's say we pick one point, pick any point. So the easiest one will be 0, 1. Okay, so 0, 1, so that means the r over here is equals to 1. The distance is 1. So x is 0, y is 1. Okay, and then we can find sine 90 degree is y over r, which is equals to 1. Okay, and then cos 90 degree is x over r. X is 0, so we get 0. And then tangent 90 degree is y over x. So this one is 1 divided by 0. So this one is actually undefined. We cannot find the value for tangent 90. Okay, and then an angle theta in standard position with terminal side passing through -3, 0. So again we can draw. So -3, 0 is over here. So basically the angle is here. So the angle is 180 degree. So over here is -3, 0. So the x is -3, y is 0, and then r is actually the distance, which is 3. So we can find sine 180. This one equals to y over r, which is equals to 0. And then cos 180 degree equals to x over r. And then this one equals to -3 over 3, which is equals to -1. And then tangent 180 degree equals to y over x. So the y is 0 divided by -3, which is equals to 0. Okay, if an angle is in standard position and its terminal side lies along the x or y axis, then we call the angle a quadrantal angle. So for example, this one is on the positive x-axis, so this one is 0 angle. And then this one, the terminal side lies on the positive y-axis, so this one is the 90 degree. And then this one, the terminal side lies on the negative x-axis, so this one is 180, and then this one is 270. And then last one, we have this one, the 360 degree. Okay, this one I put in the table the trigonometric function, the sine, cos, tangent, and also the cosecant, secant, and cotangent for the quadrantal angles. So you can see this table. Okay, let's look at example. So sketch an angle measuring -270 degree in the coordinate plane, and then give the three trigonometric functions of the angle. So note that some of the functions may be undefined. So let's sketch first. So since we have negative, so basically we count clockwise, okay, from the initial side. So it will be around here. The terminal side will be around here. So from here to here is the negative 270 degree. So if we count and counterclockwise, actually we will get 90 degree. So we want the three trigonometric functions. So we want sine 90 degree. And then from the table we get this one is equals to 1. So this one is actually sine. Okay. So sine negative 270 degree is equals to sine 90 degree, which is equals to 1. And then cos negative 270 degree is equals to cos 90 degree, which is equals to 0 from the table. And then tangent negative 270 degree equals to tangent 90 degree, which is equals to undefined. So this one, the 90 degree, the function actually we found earlier. The one where we use the formula for the x, y, and r. Okay, now we want to look at the signs of trigonometric functions. So before this, I introduced the quadrant 1, 2, 3, 4. Okay, and then for each quadrant, so let's say the quadrant 1. So for this one, actually all functions are positive. All are positive. Okay, and then for quadrant 2, only sine. So the sine and the reciprocal function of the sine, which is the cosecant theta. And then for quadrant T, the only tangent is positive. So this one tangent and the reciprocal function, the cotangent. And then quadrant 4, only cos function is the positive, which is cos and the reciprocal function, secant theta. Okay, so I summarize inside this table the positive and negative sign. And then this one is the graph of trigonometric function. Okay, over here is the graph of sine x. And then this one actually we have this one from 0 to pi and then to pi. So basically this one is in the radian. This one is actually equivalent to 360 degree. So the period here we call 2 pi. So if you look at this function, it's actually periodic. So we call this function periodic because it has repeated pattern. So this one we have like this repeated pattern. Okay. So that's why we call periodic. And then period is like where we do one complete rotation. So this one is one complete rotation. And then we will continue like this, like this. So that's why the period here is 2 pi to get one complete rotation. And then this one is the function cos x. So we start from 1 here. We go down to pi, which is negative 1. And then we go up to 2 pi, which is 1. So again, the period is 2 pi, one complete rotation. Okay, and then this one is the function tangent x. So at 0 is 0. And then we goes up to infinity actually. Okay, and then basically it goes up to infinity at theta equals to pi over 2. And then at pi over 2 also, from negative infinity goes up to 0 here at pi, and then goes up to infinity at 3 pi over 2. And then this one like this. So this one, if we want to complete one, if we want to make one complete rotation, it's actually from here up to here. So this one is the period, which is only pi. That's why the period is pi. It's not 2 pi for tangent. So now we want to learn about inverse trigonometric function. So this one we denote, so let's say we want to learn about inverse sine function. So we denote as sine to the power of negative 1. So we call sine inverse of x. Or we can say arc sine x. So the inverse function is actually undoes the original function. So let's say if we have sine theta equals to x, So that means we have angle theta. So we want to find the sine function. So we get x. So the inverse function is actually undoes that. So sine inverse of x is equals to theta. So let's say over here the theta is pi over 2. So we want to find this one. Example sine pi over 2. So sine pi over 2 will give the function equals to 1. So the sine inverse of 1, this one, basically we want to find angle which will give this one, the value of 1. So from here we get pi over 2. Okay, but if you look at this, if we draw this one, the line at 1, so basically this one also we get 1. The sine equals to 1. Where the angle is, this one, negative 3 pi over 2. So since this one, the function is periodic, is like repeated pattern like this, so we can find infinitely many angles that give the sine equals to 1. So we have this one, many angles. So that's why for this one, so sine inverse of x is actually find the angle in degrees or radian whose sine value is x within a specific range. So for this question, it's actually really important to look at the range. If there is no range, that means we have to list all the possible angles that will give the x. Okay? Okay, so the same goes to cosine function. So the inverse denoted as cos to the power of minus 1x. So we just said cos inverse of x or arc cos x. So let's say over here the pi over 2. So cos pi over 2 we get 0, the function here. So the inverse of 0 is actually equals to pi over 2 and also some other angles that give cos 0, which is this one and then this one. Okay, so the range is important. If you have the range, we only list out the angles within that range. Okay. So let's say the range over here, it says the range is, the angle is from 0 to 2 pi. So then this one, for this answer, we get theta is actually equals to pi over 2. And then this one only 3 pi over 2. That's it, only 2. Because this is the only two angles that is within the range. Okay, and then same goes to tangent function. So the inverse tangent denoted as this one, tangent inverse of x or arctan x. So let's say we want tangent pi, so pi is over here. So tangent pi equals to 0. So the tangent inverse of 0. So we want to find the angles such that tangent equals to 0, which is we get this one, pi, and then we get also 2 pi, negative 2 pi, and so on. Okay. So basically the inverse function is crucial for solving trigonometric equation and then finding the angles in right triangles. So this one is very important not to confuse the sine inverse with the 1 over sine x and then the cos inverse with 1 over cos x and then this one. So basically this one is the inverse function over here. Below here is the reciprocal function. So it's not the same. Okay, let's look at example. Okay, find the following values. So for this one, so we look at inside this one first, inside the bracket. So this one, okay, pi over 4. So if we draw, So this one is pi. So pi over 4 is actually over here. So pi over 4 give 45 degree. Okay, and then so this one is equals to sine inverse of, so we calculate sine pi over 4. So this one equals to 1 over sec 2. So sine pi over 4 equals to 1 over sec 2. And then if we draw this one, let's draw the sine function. So we have this one, and then we have again this one, and then this one also we have again like this. Okay, let's say this one is pi, and then pi over 4 is somewhere around here. So this pi over 4 give over here is 1 over sec 2. And then now we want sine inverse of 1 over sec 2. So basically we want to find the angle that gives the sine equals to 1 over sec 2. So if you look at this, we want, since it's not given the range, so basically we want everything of this angle, everything that give sine equals to 1 over sec 2. So how to get this one? Okay, so this one, so the easiest way will be, so we draw the 4 quadrants that we have. Okay, and then we look inside here, inside the inverse function. So we have positive or negative value. Okay, so once we draw the 4 quadrants, okay, let's put this one first, the sine. So all, and then this one is sine positive, tangent positive, cos positive. Okay, and then look at inside this one, the inverse function. So we have the positive value. So that means the angle will be in the first quadrant. This one, the first quadrant and second quadrant for the positive value. Okay, and then we draw this one, the reference angle. Draw the reference angle. Okay, and then we find the angle. So actually this one you guys can press the calculator, sine inverse of 1 over root 2. And then this one will give the angle here is pi over 4 or 45 degree. So since this one is pi over 4, so for the second quadrant, we want this one. So if this one is pi over 4, so the angle here is actually 3 pi over 4. So the answer is pi over 4 and then 3 pi over 4. And then since it's not mentioned about the range, so basically we have to give all the co-terminal angles. So for example, for the pi over 4, so we have the pi over 4, and then we have like another rotation which is plus 2 pi, and then another plus 4 pi, and so on. So basically this one is actually plus 2 pi n, plus the pi over 4 plus, okay, so it's not plus, so the angle will be pi over 4 plus 2 pi n, where n is integer. And then for this one, we have, again, we find all the co-terminal angles, so 2 pi over 4 plus 2 pi n. And then put n is element of integer. So this is how we define all the angles that will give sine equals to 1 over sec 2. Since it's not given the range here. Okay, so you can try do the same for B and C. So it's not given the range, so you can list out all the angles. Okay, let's look at this one. So now we do inside this one first. So we want to find sine inverse of 2 over 3. So again, this one, since there is no range, so we have to list everything. So let's draw first the 4 quadrants, and then we put this one, the sign, all, and then sine, tangent, cos, and then inside this inverse function is positive, so that means it's the first quadrant and the second quadrants. Okay, and then we draw the reference angle. Okay, and then now you press calculator, so sine inverse of 2/3. So when we press calculator, so this one will give the angle is 41.81 degree. So basically this one is 41.81, and then over here to get the angle is actually 180 minus the reference angle. So this one is 138.19. So now we know we have sine of the angle here is 41.81 degree, and then we have the 138.19 degree, and then so on. And then now we want to calculate the sine. So basically when you press calculator, every angle here actually will give the answer equals to 2/3. So we only have one final answer for this, rather than we have infinitely many answers. Okay, so you can try for B and C. So basically you can try for the rest. Okay, now final part, trigonometric identities. So the first one, we have tangent and cotangent identities. So tangent is equals to sine over cos. So cotangent is actually 1 over tangent, so we just swap. So cotangent is cos over sine. Okay. And then the second one, we have reciprocal identity. So this one I already introduced to you guys. So cosecant theta is 1 over sine theta, and then secant theta equals to 1 over cos theta. Cotangent theta is 1 over tangent theta. Okay, the next one is Pythagorean identities. So basically for Pythagorean identities, we have these 3. Okay, but actually you only have to memorize this. Sin squared theta plus cos squared theta. And then from this, we can derive to get the other 2. Okay, how to derive is, so to get the second one, so basically we have sin squared theta plus cos squared theta equals to 1. And then we divide both sides by sin squared theta. So this one, sin squared theta divided by sin squared theta plus cos squared theta divided by sin squared theta equals to 1 over sin squared theta. So this one is 1 plus, and then this one actually equals to cos over sine. We know from before is this one. Cos over sine is cotangent. So this one we get cotangent theta squared equals to 1 over sine squared theta. And then we know 1 over sine is cosecant. So this one is cosecant squared theta. Oh, sorry, this one is actually we get the last one, the last part. So to get the second equation, sin squared theta plus cos squared theta equals to 1. So to get second equation, actually we divide by cos squared theta. So this one sin squared theta divided by cos squared theta, we get tangent squared theta plus cos squared theta divided by cos squared theta, we get 1 equals to 1 over cos squared theta, which is secant squared theta. So we get this one, the second one. So the trick is memorize only this one, which is simple. Sin squared theta plus cos squared theta equals to 1. Okay, next one is even or odd formula. Okay, so for sine, negative theta is equals to negative sine theta. And then cos negative theta equals to cos theta. And then tangent negative theta equals to negative tangent theta. So this one over here, the cos, we call as even function. So even function is when f of negative x is equals to f of x. And then sine and tangent is called odd function. So odd function is when f of negative x is equals to negative f of x. Okay, and then the reciprocal function will follow this function. Okay, so only cos is the even function. So cos of negative theta equals to cos theta. Okay, next one, the identity is the double angle formula. So we have sine 2 theta is equals to this one, 2 sine theta cos theta. Okay, for cos 2 theta, so we call double angle because this one, the theta here is 2 theta. So for cos 2 theta, we have 3 formula. So this one is the first one, second one, third one. So all 3 can be used. And then tangent to theta, we have this one formula. So basically, the way we derive this is actually from this function, this formula. So we have sin A plus B equals to sin A cos B plus cos A sin B. So now A and B both are theta. So we get cos 2 theta here, sin 2 theta here. So equals to sin theta times cos theta plus cos theta times sin theta. That's why we get 2 sin theta cos theta, which is this formula. So the same for this one. So cos 2 theta is actually cos theta plus theta. So we put theta here. So that's why we get cos squared theta minus sin squared theta, which is this one, the first one. And then to get the second and third, actually you use this one, the Pythagoras. Cos squared theta plus sin squared theta equals to 1. So you just substitute this one. Or this one. Okay, let me explain clearly. Okay. So let's say for this one, we can have cos squared theta equals to 1 minus sin squared theta. And then you substitute this one inside the cos squared theta here. And then you get the third one. And then the same thing, we have sin squared theta equals to 1 minus cos squared theta. So we substitute sin squared theta, which is 1 minus cos squared theta, inside this cos squared to get the second one. And then tangent to theta, we use this formula. So tangent theta plus theta. So this one is theta. So that's why we get this one. Okay, the last one is half angle triangle, half angle formula. So the half angle we call half angle because over here is half angle theta over 2. So basically these are the half angle identity formula. So we get this is actually we derive from the double angle formula. So we derive this one, sin squared theta equals to 1 minus cos 2 theta is from this one. we get this. Okay, and then we sin theta equals to plus minus square root 1 minus cos 2 theta over 2. Okay, and then this one is theta, so anything with theta we just divide by 2. So we have sin theta over 2 equals to plus minus square root 1 minus cos 2 theta divided by 2 is like cos theta over 2. So that's where we get this one. Okay, and then for the cos theta over 2, actually we get from here. We get from this formula. We get this one. And then we do the same thing and we will come up with this. For the tangent theta over 2 is actually equals to sin theta over 2 divided by cos theta over 2. So that's how we get this one. Okay, now we finish everything. So we can use everything that we have learned to solve trigonometric question. Okay, let's look at example 1. So example 1 is actually we want to prove each of the following identities. So when we want to prove identities, so we have the left side and also the right side. So it's either you start from the left and then you get the expression on the right, or you can start from the right and then you get the expression from the left. So let's say this one, I want to start from the left. So I have tangent x sin x plus cos x. So we know tangent is equals to sine over cos. So we have sin x over cos x times sin x plus cos x. And then this one equals to sine squared x over cos x plus cos x. Okay, and then this one actually cos x over 1. So we want to make the denominator the same. So we multiply both by cos x. So this one we get sine squared x over cos x plus cos squared x over cos x. Okay, and then this one actually, since denominator is the same, so we can combine. So equals to sine squared x plus cos squared x over cos x. And then we know from Pythagorean identity, sine squared x plus cos squared x equals to 1. So this one equals to 1 over cos x. And then we know 1 over cos x from the reciprocal identity. This one equals to secant x. So we prove. From the left, we get the expression on the right. Okay, so let's look at B. So we have 1 over tangent x plus tangent x equals to 1 over sine x cos x. So this one I want to start from the left. So 1 over tangent x is actually cotangent x plus tangent x. And then we know cotangent x is cos over sine. And plus tangent x is sine over cos. And then again, we want to make the denominator the same. So this one is actually cos x. Cos x times cos x, we get cos squared x. Plus, and then on the second term, we multiply everything by sine x. So we get sine squared x. And then the denominator will be sine x cos x. And then we know cos squared x plus sine squared x equals to 1. So we get 1 over sine x cos x. And then we already proved this one. So you try C and D. Okay. Now let's look at number 2. Okay, solve the equation 2 cos squared x plus sin x equal to x. And then we are given the range here. X is from 0 to 2 pi inclusive. So basically 0 to 2 pi is everything. Okay, so how to do this? So we want to solve 2 cos squared x plus sin x. And then the one we bring to the left, so minus 1 equals to 0. Okay, and then this one we use we know Pythagorean identity, sin squared x plus cos squared x equals to 1. Okay, and then we have cos squared x equals to 1 minus sin squared x. So we substitute this inside the cos squared. So we get 2 and then bracket 1 minus sin squared x and then close bracket plus sin x minus 1 equals to 0. So we expand the bracket, so we have 2 minus 2 sin squared x plus sin x minus 1 equals to 0. So for this one we can simplify. So we get negative 2 sin squared x plus sin x plus 1 equals to 0. So this one we can factorize. So when we factorize, we get 2 sin x plus 1. And then another bracket is sin x minus 1 equals to 0. So this gives two solutions, which is sin x equals to negative 1 over 2. And then another one is sin x equals to 1. Sin x equals to negative 1 over 2 or sin x equals to 1. So we solve one by one to get x. So first we solve this one. Sin x equals to negative 1 over 2. So to get x, is actually this is where we want to find the angle such that the sine is equal to negative 1 over 2. So this is where we use the inverse function. So this one, x is equal to sine inverse of negative 1 over 2. Okay, this one, we draw 4 quadrants. So we put this one. Okay, and then inside the inverse function, we have negative. So that means this should be in the third and fourth quadrant, the negative sign. Sign is negative, should be in the third and fourth quadrant. So we can draw the reference angle. So over here is theta. Okay, but first we find the reference angle in the first quadrant. So you press the calculator, press the positive one, sine inverse of half. So the sine inverse of half is actually give the answer here, theta equals to 30 degree. Or this one is actually pi over 6. Okay, so over here equals to 30 or pi over 6. Then we can get the theta in the third and fourth quadrant. So in the third quadrant, we have this one, which means 180 plus 30, or if you want to use in radian, will be pi plus pi over 6. So this one will be, in degree, will be 210 degree for the third quadrant. And then for the fourth quadrant, we have here up to here. So which is this one, 360 minus 30 degree, we get 330 degree. So this one is in degree. So if in radian, we have over here is 7 pi over 6. And then over here is 11 pi over 6. So this one is for the first one. Now we have another one. So we have sin x equals to 1. So x equals to sine inverse of 1. So this one, actually we can use the graph function. The graph. So the sine is this one. Over here is pi, over here is 2 pi. And then this one is pi over 2. So we know the angle that will give sine equals to 1 is actually the pi over 2. It's only one angle from 0 to 2 pi. So this one we get the x equals to pi over 2. So the final answer is actually we have three angles for x within the range 0 to 2 pi. So the answer is 7 pi over 6 and then 11 pi over 6 and then pi over 2. Okay, let's look at question 3. So we want to solve square root 3 sin x minus 2 sin x cos x equals to 0. And then x is from 0 to 2 pi and then 2 pi is not included. So if you look at this, we have the same term here sin x, so we can factorize sin x. So we factorize sin x, we get sec 3 minus 2 cos x and then close bracket equals to 0. So for this one, first we have sin x equals to 0 or this one inside the bracket. So sec 3 minus 2 cos x equals to 0. So when we solve for this, we get cos x equals to sec 3 over 2. So let's solve one by one. So we solve this one first. So x equals to sine inverse of 0. So this we can use the sine graph of the sine. So over here is pi, this one is 2 pi, this one is 0. So the one, we want to find angle that gives sine equals to 0. So basically, the angle is actually this one. The sine equals to 0 is over here. So we have 3, 0, pi and 2 pi. But remember, 2 pi is not included. There's no equal sign. So the answer here is only 0 and pi. Okay, and then now we want to solve the next one. So we have s equals to cos inverse of sec 3 over 2. So again, this one, we draw this one, the fourth quadrant. And then put this one. And then look at inside the inverse function is positive. So that means it will be the first quadrant and the fourth quadrant. So we draw the reference angle. So when we click calculator, actually we get the angle that will give the cos equals to sec 3 over 2 is equals to 30 degree. Or pi over 6. So this one straight away get this one equals to pi over 6, and then the last one on the fourth quadrant is actually equals to 11 pi over 6. Okay. So then we can list out all the x equals to 0, pi over 6, and last one is 11 pi over 6. So question 4 and 5, so you guys can try yourself. Okay, and then I think that's all for today. Okay, thank you everyone.